Let's see how we did. Remember the sign outside my door. This warm-up is an example of my expectations for where your brain should be at when you walk in my room. So let's see how we did. Filling in the table. What should go underneath the 3? What should go underneath the 3? Dalton? Should be 6 pi. What should go underneath the 4? Brian?
8 pi.
Should be 8 pi. What should go underneath the 5? Alyssa? 10 pi. And what about the first differences? What should go right here? Davis?
2 pi.
2 pi. Should already start seeing something. What should go in that position? Michaela? 2 pi. And you will see that the first differences are all the same, which is where you can now see the pattern. But now you need to take that pattern and form a conjecture. That is part B. I even gave you part of the conjecture. How the circumference changes with each 1 unit increase in its radius. So you could have started out your conjecture. For every 1 unit increase in radius, what happens? So what was your conjecture? What was your conjecture? Brandon and then Sebastian.
Multiply the unit of radius by 2 pi.
Okay?
As 1 unit increases in the radius, 2 units increase in the circumference.
Well, that's partially correct, but you left out pi, and that made it incorrect. It's not an increase of 2 units, it's an increase of 2 pi units. Remember, pi is a number. It's close to 3. So 2 pi is close to what number? If pi is close to 3, what's 2 pi close to? Catalina? 6. So really what's happening is it's increasing by approximately 6 each unit. So each increase of 1 unit of radius increases the circumference by 2 pi units. So I don't care exactly how you phrased it, but it should have said something about increasing 1 unit of radius and increasing 2 pi units of circumference. There's a relationship. As radius increases, so does the circumference. But how? Part C, you were asked to determine the actual length of fencing. You could have done it a number of different ways, but we've got all this information, and I was hoping you would have used it. What'd you get? Just 2 people figured it out? So I'm going to be using the equity bars a lot today. Let's start out right now. Start getting people involved. If that makes you uncomfortable, then get yourself involved ahead of time. So we're going to number 6, number 15, and number 21. Where's number 6? Where's number 15? And where's number 21? Okay, what'd you get? Okay. Well, unfortunately, that's not a radius of 280 feet. That's a circumference of 280 feet. You're confused about what a radius is and a circumference is.
Oh, no, that's...
Yeah, you were thinking of diameter. But you had a, you were onto something. Maria, what'd you get?
I thought I had to do radius, so it would be like... I did radius, I did put in the circumference.
So what was your answer? Are you not sure? Okay, Michaela?
I know 1,060.
Okay. So the correct answer is 324 feet. So let's back up for a second. Give me a thumbs up if you drew a picture. Okay, so I got 1, 2, 3, 4, 5, 6, 7. Put your thumbs down. 7 or 8 people out of 22. You're in geometry honors. And you didn't draw a picture? That was mistake number 1. Now, of course, drawing a picture is not everything. You actually have to understand the picture. So here's my beginning of my picture. Here is the pond, and here's the radius of the pond. We know that this distance around here is 280. So we know that the distance around, that's called the circumference, is 280 feet. And what we want to figure out is what's the circumference of this. And this was the picture you should have drawn. So we have the circumference of this circle. I want the circumference of this circle. How am I going to get it? You actually had several different ways you could have done it. But let's use the conjecture. Each increase of 1 unit of radius increases the circumference by 2 pi units. You're being told right here, if I increase the circumference by 1 unit, what's going to happen to the circumference? So the situation is that you have a circumference of 280 feet, but now we're going to increase the radius. So watch what we should have done with our picture. You should have added in this piece right here and labeled it. What should the label be? Dalton?
Increase of the radius?
Which is? Well, now,
7.
yeah, it's 7 feet. That's 7 feet right there. So this radius we do not know. So that's what made it confusing, right? But you don't need to know it, because you figured out this. For every increase of 1 unit of radius, we increase the circumference by 2 pi units. If I take this circle and I extend the radius 1 unit, if I extend the radius 1 unit, what will happen to the circumference? Ania? I will add 2 pi, which is approximately 6, right? Close to 6. So what would, if I increase the radius by 1, so that would be to about there. If I increase it by 1, my new circumference will be 286 approximately. What if I increase it by 2? What will happen to the circumference? Tristan? How'd you get that? Another 2 pi. And how would I know that? If I increase this by 2, look at what is in my table. An increase by 2 increases the circumference by 4 pi. What if I increase it by 3 units? How much will the circumference go up? 6 pi. So what's missing from my table that would be very helpful? Because it's not increasing by 1, it's not increasing by 2. What is it increasing by? Davis?
7.
So what should be in my table?
That's 6 and 7.
The 6, well, we don't need the 6, but yeah, we could put it in. But I need the 7. But do I really need to write it in? Could I just figure it out based on the pattern? So that's why I don't really need the 6, but again, I'll put it in there. So we've got 6 and 7. What should go right here? What should go right there? Jada? 14 pi. So if I increase the radius by 7, the circumference is going to increase by 14 pi. So isn't that exactly what happened? That we increased the radius by 7, and so we increased the circumference by 14 pi. Well, what number do we usually use for pi as an approximation? Sebastian? 3.14. Take out your calculator. 14 times 3.14 is about 44 feet. So we end up with 280 plus 44. 324 feet. There was another way to do it that didn't involve any of this. I'm surprised nobody figured it out. I had the circumference formula up there. Brandon, you figured it out?
Yeah, I divided 80
By what?
I divided 80 by 2
Yeah. If circumference equals 2 pi r, and you don't know what r is, 280 is the circumference equals 2 pi r. How would you solve for r? Divide by 2 pi, divide by 2 pi. Pi we already know is 3.14, so take out your calculator. 2 times 3.14, so 6.28. 280 divided by 6.28, that's not an 8. 280 divided by 6.28 is 44.59. So we now know this number that was missing right here is 44.59 approximately, the radius. Now we could take that, add 7 to it, and find the new circumference.
I did that, but I got 327.
Okay, so mark it right.
I did the same thing, but I took it a step too far. I tried to put it into
Okay, well, do you see how it makes sense this way? Okay, so that canceled that, we got that. Good. Now, honestly, I didn't really want you to do that, what I wrote in red. I wanted you to use the table, but, you know, the idea was to really get an answer. So I apologize. I didn't even think of this method until you guys were in the middle of it, and then I realized that you could do it this way as well. So I put 324, but if you got anything close to 324, I would accept it. Because if you round differently, if you didn't round to 44.59, what if you rounded to 44.6? You'll get yet a different answer. So if you got anything close to 324, I'll take it. Any questions about the intended idea? About this right here? Any questions about that? Nothing at all? All right, let's hit the pause button. Last time we were together and the introduction on Monday to the chapter, we talked and introduced the idea of conditional statements. Today we're going to start working very formally with conditional statements, writing them, analyzing them, and learning more about what comes next. So, your objectives for today are to learn how to identify and write and understand, analyze the truth value of conditional statements. That's what we're going to focus on today. 2.2, which is today's lesson, is actually going to be broken into 2 parts, and we're going to do the first half today and the second half tomorrow. The second half is when we're going to learn how to write the inverse, converse, and contrapositive. This is the point in the curriculum where things get extremely difficult, challenging, confusing. I will be standing up here and I will be teaching you, and I, in my head, will be getting confused. That's how confusing it is. As I said to you before, there will be moments where you are perfectly clear, and then in the next moment you will become confused again. So you have to put yourself in the frame of mind that this is all about perseverance. Has nothing to do with math. It's all about perseverance. We're going to start with the basics and work our way to the more complex today. So, the vocabulary you're going to hear, the first 4 terms we're going to use a bunch of times today. Conditional statement, hypothesis, conclusion, and truth value. Negation, converse, inverse, and contrapositive will come next time. So, what is a conditional statement? What's the hypothesis? And what's the conclusion? A conditional statement is what you learned last time. A statement that can be put in the form of if, then. If P, then Q. This can be written in symbols, which you learned already. P arrow Q is red if P then Q. This can also be represented in a Venn diagram. P is the innermost circle, Q is the outer circle, and then the rectangle is the universe. So now what is P and what is Q? The hypothesis is P. And it's the statement following the word if. So it's the if part of the statement. The conclusion is Q. And that's the then part of the statement. So again, this is read if P then Q. This is also read if P then Q. When we take a conjecture, like the ones you learned how to form last time and during today's warm-up, and we phrase it as an if-then statement, we can quickly pick out the hypothesis and the conclusion. This is very different than anything we've ever done together, especially since I've been with you for 2 years. Today, you're not going to be doing very much math. You're going to be doing a lot of writing. Today, you're going to need to get your brain to start functioning in a slightly different way. You're going to have to open up your mind to a new way of viewing things. You're going to stumble, I guarantee it. You're probably going to stumble right out of the gate. But with time and perseverance, it will start to make sense. Are there any questions about these different definitions and the symbols and the different ways of writing? Because we're going to jump right in now. All right. Example 1. Identifying parts of a conditional statement and rewriting statements in the if-then form. Today is going to be a lot of writing. You might get tired. It's just the way it is. You do not need to copy the instructions, but you need to read them carefully. But you do need to write each example because everything's going to be based off the example. So first, we want to rewrite the conditional statement in if-then form. Then we want to identify the hypothesis and the conclusion. So if-then form first, then hypothesis, then conclusion. The given statement is, if today is Thanksgiving Day, then today is Thursday. That is the given statement. We would like to rewrite it in if-then form. You may have no idea what I'm talking about, but let's go ahead and give it a shot. I'm going to go to the equity bars right off the bat. And let's go to number 7. Number 7. What would that be in if-then form? Okay. Well, remember I said a moment ago that you might stumble right out of the gate? Fung, you had a different thought? Yeah, it's already in if-then form. So it was somewhat of a trick question. It's already in if-then form. You don't have to change anything. It says if, the hypothesis, then the conclusion. This is a conjecture. So it's already in if-then form, so now we can identify the hypothesis. I will allow my students to just write an H for hypothesis and a C for conclusion, so you don't have to write the words over and over and over again. But you need to clearly label things so I know what you intended. And yes, if you mix them up, it is incorrect. So, what is the hypothesis from this conditional statement? What's the hypothesis? Anit? Well, you're missing some of the words. Today is Thanksgiving Day. That is the hypothesis. Today is Thanksgiving Day. So what is the conclusion from this conditional statement? Tristan? Today is Thursday. If-then statement, hypothesis, conclusion. So that's basics. Any questions so far? And we're going to build from there. Any questions? All right. A number is a rational number if it is an integer. So, first we want an if-then form. Any brave student want to give it a shot? I've got a few brave students. We'll start with Michaela, and then Chris, and then Daniela. Michaela, what do you think the if-then form is?
If the number, if the integer,
Well, you had the right start the first time. Chris, I'm sorry, she stole your thunder. Danielle, I'm sorry, she stole the thunder. That was exactly it. If a number is an integer, then the number is a rational number. So that is the if-then form. If a number is an integer, then it is rational. Now that it's in the correct form, we can easily pick out the hypothesis and the conclusion. And I apologize, there were several of you who had volunteered for this one, and that was brave of you, and I really appreciate it. I'm sorry I didn't get to everybody. So what is the hypothesis here, Chris? A number is an integer. And what is the conclusion, Danielle? The number is what? I'm sorry? It is rational. Very good. Any questions about hypothesis, conclusion, writing it as an if-then? All right. Part C. Two angles are supplementary if they are a linear pair. So, what do you think the if-then is? 6 people who feel uncomfortable, 7. Start with Catalina, Brian for retribution, and then Davis. What do you think, Catalina?
If two angles are linear, then they are supplementary.
What do you think, Brian? Say it one more time.
If two angles are linear pairs, then they are supplementary.
That's right. If two angles are a linear pair, then they are supplementary. and the hypothesis and the conclusion. What's the hypothesis in this case? The hypothesis. Dalton, and then we'll go to Ania.
Two angles are a linear pair.
2 angles are a linear pair. And so what's the conclusion, Ania? They are supplementary. Very good. Does anyone have any questions about how this was all put together? Again, this is foundation. We haven't even gotten to the real work yet. This is just learning how to read, write it out, and identify parts. Okay, let's take it one step further, and I already introduced the idea of a Venn diagram. So here's a Venn diagram, and you're going to need to just sketch it on your paper. It doesn't need to be perfect. I have a computer that does perfect stuff for me. But from the picture, we are going to write an if-then statement. See if you can put it together in your mind. So, what do you think it's going to be? 2 people have an idea? 3 people? Same people? Okay, I'm going to keep calling for volunteers, but next round I'm going to go back to the equity bars. Okay, so we got Davis and then Brandon. Davis, what do you think it's going to be?
If it is a blue jay, then it is a bird.
Okay. If it is a blue jay. Okay, Brandon, what were you going to say?
If they're blue jays, then they're birds.
Okay. If they are blue jays, then they are birds. Okay. If what are blue jays, and then they are birds? Because you said it, and you said if they. What are you referring to? What would be represented by the universe in this case? What would the big rectangle represent?
Blue.
Tristan?
The animal.
Yeah. If an animal is a blue jay, then it is a bird. But you guys were right. Bless you. Davis, Brandon, you were right what you said. I just wanted you to think about being more specific, being as specific as you can. So with a Venn diagram, the hypothesis and the conclusion are easy to pick out visually, and after putting it into words, it's easy to pick out. The hypothesis is always the innermost, and then the conclusion surrounds it. Okay? Dalton?
The hypothesis is blue jays. I mean,
Right.
animal is a blue jay.
Right. An animal is a blue jay, and then it is a bird. Any comments, questions, or concerns on writing if-then statements, identifying hypothesis and conclusion? Any comments or questions? All right, give it a shot on your own. You got 2 different statements. Rewrite the conditional statement in if-then form, and then identify the hypothesis and the conclusion of the statement. You've got part A and part B. You got 3 minutes. got 1 minute to team talk to compare your if-then statements with your teammates. If you're still trying to finish up, that's fine too, but this should be discussion time. You can just pass your paper if you want them to just read it, or you can read it to them.
First divisible by 6, then the number is divisible by 3. And then type 5, the number is divisible by 6, and then the if two angles are
All right. So let's see how we did. Part A, what was the if-then form of that? Should be feeling confident at this point to be able to share out. We'll start with Alyssa and then Janae. What'd you put, Alyssa? What did you put, Janae? Same exact thing? So that's pretty much what I put. If a number is divisible by 6, then, I should say then, I apologize for that typo, then it is also divisible by 3. Sorry about that. And so the hypothesis and conclusion, once you get that, should be pretty basic for you at this point. Second one was a little bit harder. What did you get as the if-then for part B? We'll start with Jada, then Maria, and then we'll go to Tristan if we need more help.
If two angles are complementary, then they are.
Okay,
If two angles are complementary, then they are acute.
so you agree. Give me a thumbs up if you agree with what they put. Because I heard some other things. Okay, Davis, what was yours? Wait, Dalton, what was yours?
If two angles are acute, then they are.
Okay, so you switched it around. Okay, did anyone do the same thing as Dalton? Because I had heard a number. Okay, you did it, okay. There as well. So, in this case, it had to be if two angles are complementary, then they are acute. I understand why you flipped it around, because it was hard to tell. But you can tell which one's the if statement. It's a little bit weird because of this word right here. Two angles that are complementary. So that's kind of saying that this is going to come first, then that part's going to come. The other issue is this. It doesn't work the other way. You're going to learn more about that in a few minutes. Michaela.
Conclusion for A, I think it would make sense when you read it out loud.
No, it doesn't because there's another typo. A number is also number is. Yeah, you think that's not good? Not good grammar? It is also divisible by 3. Yeah, that's not supposed to be there. Yeah. There we go. It is also divisible by 3. Thank you for reminding me. I caught that earlier and I forgot to change it. Any comments, questions about writing in if-then form and then identifying hypothesis and conclusion? Good. Now we've laid the foundation. Now we can work on truthitude. That's not a word. A conditional statement has a truth value. It is either true or false. It is only false when the hypothesis is true and the conclusion is false. This is incredibly important. In a few minutes, your brain is going to start melting, literally melting and seeping out of your ear and dripping down your neck onto your clothes. If that happens, take out a paper towel, wipe it up, get back in the game. But coming back to this statement is going to ground you. It's going to bring you back to some place that you can feel comfortable with. Because your brain is not going to accept what I'm going to tell you. My brain doesn't accept what I'm going to tell you. Because it's difficult. So a conditional statement is only false when the hypothesis is true and the conclusion is false. Here's the part that you learned last time about counterexamples. But now we're applying it to the whole the idea of conditional statements. All you need to do is find one counterexample, and that will disprove the conditional statement, making it false. If you have no idea what I'm talking about, good. That's probably how it's going to stay. So let's go ahead and start the adventure. So, example 3. Analyzing truth value. Determine if the conditional is true. If it's false, then state a counterexample. All you need is one. This is also where your brain needs to start thinking of statements a little bit differently. So the first conditional statement is, A, if this month is August, then next month is September. So now here's where I struggle personally. My mind is looking at that as an example. But it's not an example. It's a statement. It's a broad statement. And now I have to come up with an example to apply to it to test it out. So, if this month is August, then next month is September. Now I have to test that out. Let's test it out. It's September right now, right? So let's put September into it. This month is September. Well, that doesn't apply, does it? So that example doesn't work because it doesn't even apply. We can't use it because it doesn't meet the condition of the if part. So this case only works if the current month is August. So let's use August. Let's pretend for a moment that it's still August. If this month is August, then the next month is September. Is that true? Is that false? Or somewhere in between? What do you think? You had been waiting, Dalton.
Oh, true. But I was gonna say, like, isn't it like the symmetry angles in a cube? Because it's not true.
We'll hold on to that for a few minutes. Okay? So if it's currently August, then the statement is true. Is there any case where it's August but the next month is not September? Is there any case where this would be true and this would be false? Is there any case that you can think of? David.
The end of the world.
Barring the end of the world, so you're assuming the end of the world is going to happen in August. Interesting choice. So, it's going to be on your birthday? The end of the world?
Like, that's my birth month.
Oh, and you're going to celebrate by causing the end of the world? I'm confused. What are you saying?
Like, why
Do you have superpowers that we're not aware of?
Yes.
Okay. That's true, you do. So, I'm just joking around. Yes, Chris?
Unless the month September gets a different name, then both statements are true.
If September gets a different name,
Yeah.
what name is it going to get?
I don't know.
Okay, so we're not trying to come up with some fantasy, we're trying to come up with real, actual examples. So I appreciate you trying, but in fact, there is no situation in which this would be true and that would be false. And as you saw a moment ago, if the hypothesis is true and the conclusion is false, then the whole statement is false. Otherwise, it's true. So what we have just proven, is that this statement is true because this is true and end, the conclusion is true, the whole statement is true. Yes, Anita?
To prove that the statement was false, all you have to do is
You just need one counterexample to prove it's false. But there is no example of the month being August and the next month not being September, except for Davis's Fantasy World and Chris's made-up name. So, if you have questions, hold on to them for a second. Now let's look at part B, which is not the same question as before, but similar. If two angles are acute, then they are congruent. So, if it comes out like this, true, true, then it's a true statement. If it is false, false, then that's actually a true statement. We'll talk about that in a moment. That's where your brain's going to start to melt. The only time that the whole statement is false is if we have true and then false. And for that to happen, we need one counterexample. So, let's see what we can come up with this one. If two angles are acute, then they are congruent. So I'm going to show you my example that proves this to be true. So here's my example of this. And so I went and measured these, and that is 25 degrees, and that is 25 degrees. And those are two acute angles, and they are congruent. So that's a true statement.
Yeah.
Okay, Fung?
Let's see. 35 and 25.
35 and 25? Okay, so are those both acute angles?
Yeah.
Hold on, excuse me, because some of you are going to miss this and you're going to get lost. So say your proposal again.
35.
Okay, I'm going to sketch this, and it's going to be very rough, just in the interest of time. So I've got a 25, but then a 30. That's not very good. 35, a little bit bigger. And so you're saying that those are two acute angles. So this is true. These are acute, but then they are not congruent, you're saying? And so this part was false. Because that's true and that's false, that makes the statement false. And so what Fung has just done has proven that this is a false statement. For it to be true, it has to be true all the time, or it has to be false all the time. But if it's true and then false some of the time, that's a false statement. Okay? Questions about that? There seem to be some question or comment over here. Any questions or comments? Yes, Maria?
So the hypothesis has to be true. The conclusion has to be false for the whole thing to be false.
Correct.
And what if the hypothesis is false?
Part C, and then I'll get to your question.
I know, we left again.
So, is this true or is this false? And what we're talking about is the whole statement, not part of the statement, the whole statement. And that's the difficulty here, is that you have to figure out how to get yourself to understand. We're talking about the whole statement. Brian?
Since you said on the slide before that if both parts are false and they're true, then it's true.
Yeah, this is actually a true statement, which is very confusing, and I'll be honest with you, is still to this day very confusing for me. But that's a true statement. Because, and the best explanation I can offer you is, all I can offer you is what makes sense to me. If an even number greater than 2 is prime, does anyone know an issue with that? Because you said that they're both false, Brian, right? Chris?
2 is the only
Yeah, 2, that was beautifully said, by the way. 2 is the only even prime number. There are no other ones. So this hypothesis is false. So once it's false, it actually does not matter what happens next. The statement overall is going to be true every time because this will never happen, so that will never happen. It doesn't matter. It's a true statement because it will never happen. Okay? Michaela,
I found a way to remember that easily.
go.
Kind of like negatives and positives. If you, let's say they're both false and it's negative, but if you multiply two negatives,
And I was actually going to bring that up. Have you ever heard the phrase, a double negative proves positive?
yeah.
That's exactly what I was thinking. And it's really hard because it's counterintuitive. You think, okay, negative, negative is negative, but she's absolutely right. A double negative proves positive, and so a false and a false proves positive. Comments and questions here, here, and then there. Go.
So basically 2 letters is true.
2 letters is true.
No, I'm saying two the
Oh,
same.
2 of the same letters is true. Yes.
So,
You skipped a word there, and then my mind started freaking out. Okay, so 2 of the same letter, then it's a true statement. Absolutely. Okay, Davis.
It's
Is this about the end of the world again?
No.
Okay, go on.
I just want to say that right.
Okay.
With the thing where it's 2 false is true, it's technically the opposite of 2 wrongs don't make a right.
And that's another way to, sort of. I mean, it's a related idea, but there you're saying 2 wrongs don't make a right. If we apply this, you're saying 2 wrongs would make a right, and that's not what we want. Okay? But I understand your point, okay? Good. Any comments, questions, concerns, anything at all about this? All right, let's see if you can actually apply it on your own. So checkpoint number 2. Determine if the conditional, and there it is in quotes, if a number is odd, then it is divisible by 3. Determine if the conditional is true. If it's false, give a counter example. You've got 2 minutes. So you have to first test out the hypothesis. So pick a number that's odd. Okay? Is it divisible by 3? Divisible means that's what divisible is. So it's not. So you actually put on the counter. You're saying, what if we put an even number in? I'm getting confused by what you're asking, to be honest with you. In this specific case, you're being asked to test out a hypothesis. A number is odd. Are you saying, what if that was false? The only way that could be false is if we pick an even number. Pick an even number, 4. Then it doesn't matter. So it's a true statement. Okay, so we can only disprove it by using the hypothesis as accurate. Okay, I know it's hard. Other questions? I'm going to get to you in a moment. All right, so you got 1 minute team talk to see if you agree with your teammates. Go.
Can that work? Not in this one, I'm just saying.
Well, so well in this case, like she was saying, we put an even number like 6. 6 is divisible by 3. So what do you do then? But that's not what this is talking about. So that doesn't apply. It only applies if it's part of the hypothesis. So what's your question?
If the hypothesis is false and the conclusion is right.
Yeah, see, I'm confused too. Okay, so let's survey the class. Give me a thumbs up if you think the conditional is true. Thumbs up if you think it's true. So everybody thinks it's false. The conditional is false, but now you need to prove it by giving a counterexample. What was your counterexample? We'll start with Feng, and then Anne, and then Alyssa, and then we'll come up here if we need more help. Feng.
25.
I'm sorry? 25. Is that an odd number?
Yeah.
But it's not divisible by 3. So that makes this a false statement. Who did I say was next? Anne, go ahead. 23. Okay, also same thing. Alyssa? 7, which is the magic one that I picked. Example of an odd number is 7. So it is not divisible by 3. In this case, the hypothesis is true, but the conclusion is false. And so again, that's what we're trying to do. That's where you're going to feel safe. The rest gets very confusing. So bring yourself back to your goal. You are trying to find where the hypothesis is true, but the conclusion is false. Everything else doesn't matter. That's what you're trying to do. So are there any comments or questions about checkpoint number 2? We're going right into checkpoint number 3, and we're bringing everything together. First, you're going to write the if-then form of the conditional statement. Then you're going to decide the truthitude, and then you're going to give a the truth value. Then you're going to give a counterexample if you think it's a false statement. Okay? So you got another 2 minutes, but remember, you have to write the if-then form first. No. So that was practice just to get used to it, and now that we're used to it, you should now be able to look at it and know which one's the hypothesis and which one's the conclusion, right? Thank you. Thank you. got 1 minute team talk to see whether or not you agree with your teammates. And if you disagree, discuss, try to prove, disprove, come up with counterexamples or different counterexamples, etc., etc. Go.
If there are guitar
Okay. All right. Back as a whole group. Unfortunately, the team talk for some of you devolved into silly talk, but luckily it was just a minute of it. So, first we want the if-then form. What was your if-then form? Got a bunch of people. We'll start with Janae, and then we'll go to Zabari. Janae, what did you put as the if-then form? Okay, what did you put? So you had the exact same thing, and that's actually exactly what I put. If you are a guitar player, then you are a musician. So that's the if-then. You could have put if a person was a guitar player, if a human was a guitar player, if a thing was a guitar player. You could have put a whole bunch of different versions of it, but you're starting with being a guitar player, and then conclusion is then you are a musician. Now the truthitude, the truth value. Is this true or false? If it's false, be prepared to provide a counterexample. Let's survey the whole group. Give me a thumbs up if you think it's true. So let me count because it's only part of the class. 1, 2, 3, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, sort of, 19, I don't know. So the majority thinks it's true, but we have some dissenters. And so this is actually a true conditional statement. So Kisara, what was your counterexample that you had come up with that you thought worked? That's true, but you didn't put your thumb up, so I thought, oh, I'm sorry, I didn't see it. Okay? So it was a little confusing. Again, thumb up needs to really be clear. If you go like this, I can't really tell what you're doing. So, are there any comments or questions on this? Okay? So that concludes part 1 of the lesson. Draw a line across your paper and listen carefully. And listen really carefully, because otherwise you're going to do something you're not supposed to do. On page 74 in the textbook, you are going to do numbers 3 through 15. However, in the last 4 or 5 questions, I think it's 11, 12, 13, and 11, 12, 13, 14, 15, or maybe 12, 13, 14, 15. It asks you to do a whole bunch of stuff that we didn't study yet. We're going to study tomorrow. I don't want you to do all of it. I want you to write the if-thens only. It's going to ask you to do the converse, the inverse, and the contrapositive. We didn't study that yet. So do the if-thens only. So it's a total of 13 questions. It really shouldn't take you that long. It's just a matter of writing. And then I would like you to do the animated math activity online. And you are going to have a quiz next week. And that will be on 2.1 to 2.3. We'll actually probably be pretty far ahead of 2.3 by the time I give you the quiz, because I'm going to give you the quiz later on in the week. But it will only contain 2.1 to 2.3.